the thing that I talked about, how we would kill the app if we detected this bad situation. The method is called jump ship if app is syncing.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm KaushikGopal.
Welcome to the show.
In this episode of Fragmented, we talk to Piwai from Square. Piwai is a good friend of the show, and in this one, he explains to us this concept he likes to call offensive programming, which is the opposite of defensive programming. We find out some of the cool ways and strategies he's used at Square to help debug crashes, add more information to your crash reports. He also gives us some really cool and useful tips that I've never come across. So we hope you really enjoy this show as much as we did, and stay tuned to find out more. On to the show.
Okay, Kaushik, it's been a couple weeks since we've both been on the call together. It's good to have you back, man.
Yeah, thank you. It has been. I was out on a trip to Yosemite, which is always really nice.
Did you climb the face of it with no ropes?
Well, not without ropes. There was. I definitely did use. We went all the way to Half Dome with cables. They have these cables that they lay. So yeah, I did do that. Yeah, it was fun. I was kind of broken. My body was broken the next day, but it was fun.
You're recovered now, then.
I'm completely recovered and ready to talk Android.
Awesome. So we were talking before when you came back, and we knew at the time when we were discussing this, like you said, you were kind of broken. I said, well, let's get someone on the show, and do you have anyone in mind? And you did. So who are we going to be talking to today?
So we have a good friend of the show who we have always wanted to get on, and he agreed, and we've always said, yes, let's do it. But somehow the stars never aligned, but they have today. And super smart chap, and he has a whole bunch of topics to chat about. So but there was one that piqued our interest, this concept of offensive programming.
Yep.
Which I thought was very interesting. So without further ado, let's bring our friend on the show. Welcome to the show, Piwai.
Hello. Hi, everybody.
Piwai, for folks that maybe aren't familiar with you, some of the very useful libraries that you've worked on and provided to the community, could you give folks a little bit of background on who you are, where you work, kind of what you've done in Android and so forth?
Yeah, so I work at Square, and I think I've made 2 Android libraries that had a small impact. The first one was years ago. It was called AndroidAnnotations. And it was the first annotation processor for Android that generated a bunch of code, and that was fun. And the second one is LeakCanary, which is a really great way to freeze your app while you're developing. No, it's a way to detect memory leaks.
Small impact. These libraries, a couple of people, very few people have used this, and I think Square is an upcoming company that's just gotten onto the Android bandwagon. So very new stuff. So
yeah, I should probably mention that it's actually something interesting. Before I joined Square, I knew Square because of the Android libraries, but I had no idea what Square was doing. So I should probably mention for the community, Square is dealing with payments. That's what we do. We help people take payments, and we're really good at this. But we also do Android libraries.
Yeah. Many people think Square's only sole reason of existence is to build open source Android libraries, but that is not entirely true.
That's also the secret agenda.
Good stuff.
It's one of the things that we were talking about when we were kind of before the show, trying to figure out what to talk about, as Kaushik had said, was you had mentioned something about debouncing, and then we kind of devolved into another topic of which you brought up. I think the perfect term for it was just kind of defensive programming and offensive programming and so forth. And the one that really stuck with me seemed to be, and all of us it seemed, was offensive programming. And I think that's kind of what we wanted to talk about today. But it seems kind of a higher level term. Would you mind explaining what that term offensive programming really means?
I guess there's a bit of background here. So it's just a term that's used in opposition to defensive programming. And so to talk about offensive programming, you have to talk a bit about defensive programming. So defensive programming, you might have heard that before. It's this idea that the user is going to input a lot of bad stuff into your system.
Mhm.
So you need to be prepared for that. And so defensive programming, I think, was invented, I don't know when it was invented, but was very useful for, say, C programming, where you check the inputs, and if they're wrong in any way, you try to correct them. So if someone passes you a null string, you make it an empty string, or you just try to recover in any way you can to survive the crazy input that the user or another program is passing into you. And that makes for very resilient programs, systems, system programming. But that's very useful when you have external input that you don't control. But when you're in a code base that you control and every single class is yours and you know what goes in and what goes out, then you don't really need to do that, right? You should never get random garbage from another part of the code. And so the approach with offensive, what we call offensive programming, is if you get wrong input, you just throw an exception and you crash. Actually, you throw a runtime exception and you say this is unacceptable, which is a way to enforce contracts, right? So you say, I'm never taking null ever. This method cannot accept null. And if you send me a null, I'm not going to try to deal with it. I'm going to throw an exception. And what this does is it sounds crazy because it increases the number of crashes, right? But it also increases your confidence in the code because you know, oh, okay, this can never return null. This can never accept null. So I don't need to deal with that on the call side, right? And so it forces you to write better code. Well, it has the effect of making the code more clear, but it also forces you to think more about what you're doing and to handle the bad situations.
Stepping back just a quick second. So you gave a very good definition of defensive programming. But when you say user inputs, right, it could be because, I mean, some folks, when you think about user inputs, you think about the actual inputs that the user enters. Like, if you have like an input field, you could maybe input like an invalid value or something like a 0 where you like a, maybe an alphabet when you're expecting a number or something, right? So there's like one aspect, which is where the inputs are like literally from a user of the app. And there's also where like the input is like from other parts of the app, right? For example, a common example that most folks see is like null pointer exceptions. If I'm launching from one activity to another activity, and then the other activity is like respawning and it doesn't have the input, then what can happen is like you'll get a null pointer exception because it's not constructed that object or that object is null, right? So there's like two aspects to it. One is inputs from other parts of your app, and one is inputs from the user. And I guess in both cases it makes sense, but at least definitely in the former case where it's inputs from other apps, like failing often is a good idea, right? Because you control that. Like nobody that's your problem, nobody else's problem.
Yeah, if you think about it in the context of payments, for example, right? Imagine you have a card number input. So someone can type a lot of random stuff, but there's something called a Luhn check, which is a simple sort of checksum on the numbers to tell you if the number is valid or not, right? So if you're building this, you would probably have a UI component that's a text input, and then you would have something that validates it. And if it's not valid, you would show an error to the user and ask them to type again. But once it's valid, you would take that card number, turn it into a card object, and pass it through your system. And further down the system, you wouldn't expect an invalid card number because it's supposed to be valid at this point, right? And so you wouldn't say, oh, this number is invalid. Let me try to fix one of the digits to figure out like what the right card number was.
Got it. Or you wouldn't even check to see if it's an actual valid number because you assume that it has to be valid. So there's no reason to have like this duplicate check and like complicate and like confuse someone else down the line. Like if another developer is coming and looking at something, they're like, oh, I should probably check if this number is like, no, you don't need to do that because you've checked this at like the call site, right?
Yes, exactly. That's exactly that. And so what the infect? So this is something that I learned when I joined Square, and I realized that we are very serious with assertions in the code base, and that led to a lot more obvious. So we had like state machines, and it had to be in one state or in another state, and you couldn't be in between two states, and that made everything much more obvious. And when there was a bug, we could figure out why this had happened, as opposed to a bunch of patches that you're like, oh, maybe this happened, maybe that happened, and I don't know because there's like 5 different ifs that handle all of the possible situations.
Can you walk us through like the process of how you started this? You said, because you said assertions, and I like that, but say I have a code base now. I have like this giant code base, and I'm like, okay, this POI guy seems like a smart fellow, so I want to start doing this offensive programming thing that he's talking about, right? How do I go about it? Because it's going to be pretty scary to begin with, because like you said, like there's going to be like a whole bunch of more crashes, right? Can you walk us through what that process was for you? Like when you started out and you started adding these assertion checks, like what happened? Like did your manager start complaining because the crash rates went up, but then you're like, no, I can fix it? Like just walk us through that process.
First of all, I should rephrase that when I joined Square, that was already in place. So I sort of adopted the thing that was in place. And then I started pushing it more and more on other teams, I guess. But to answer your question, what that would look like is the first thing you need is measuring the impact of what you're doing, right? So you need to have a crash handler in place and some way to measure that you're not impacting crashes too much. And then use features like progressive rollout so that you can do a release to 1% of your users and measure the crash rate and figure out, okay, the crash rate, I just added an assertion here and the crash rate went up and that's caused by this assertion. Okay, great. Now it means that, that's seriously, that's great. It's sad for the 1%, but it's great for you because now you have one place to look at. You look at the top crasher and you look at it and you think, okay, what can I? So obviously I'm throwing here, which means there's an assumption here that's incorrect. Like maybe I put an assertion and actually there's a good reason to call with a different value. Or maybe the person who wrote the code who calls me doesn't really understand how to use this, right?
I like that idea of thinking like, oh, this is good. Like, this is not wrong, because you have one data point now. You have like a established hint. The assertion's like a hint, right? Yeah.
Exactly right. So for years. Computer science, people have thought about, like academia has thought about ways to analyze, statically analyze code and find errors and that type of stuff. And we've never seen it working in the industry, at least in my experience. So this is sort of the, your second best option, which is you just let it run on in a lot of different situations and you see what comes up.
Now, what's really sitting here for me right now is I constantly think about null checking, and because that's what you do a lot of the times is you get this crash, you see it's a null pointer exception, you see, oh, I'm checking for this, and I can just check if it's null, and then I can kind of skip over that. And you said it before that it could be a much deeper issue that you need to identify, and I believe that's 100% the case, but where do you feel that Kotlin comes into this? Because a lot of folks are seeing Kotlin as like this silver bullet that, you can't use nulls or nulls aren't allowed. And I mean, I'm kind of just generalizing here, but that's kind of what they're saying. What's your take on how Kotlin is going to help, if at all, in these types of situations where, you perhaps need to check with nulls or deal with NPEs, et cetera?
Yeah. So I think Kotlin is going to be a huge improvement and it's going to help a lot. But I'm also afraid that it's seen as a silver bullet. So if you think about what's going on with a null pointer exception, aside from the fact that, null is even allowed, what's really going on is that there is a state that you didn't expect in the code, right?
Mm-hmm.
Like you had something was supposed to call something else and set a value, and then that didn't happen, and then you tried to use the value and it was null, right? So if you move to a world where null is not an option, it might make some things more visible, but if you have logic issues in your code base, you're still going to have logic issues. And if something was supposed to happen in one order and doesn't happen in that order, then you're still going to have a bug or a crash of some sort. So I do think that Kotlin's going to help a lot with making those issues more visible, because you're going to have to think about the potential more often. But there's still going to be a lot of bugs in our apps. They're just going to be, we're going to move from NPs to some other state exception error.
Right.
Mm-hmm. Now, this is a cool concept here of kind of being more offensive in regards to, crashing fast immediately. Mm-hmm. And this is also a very kind of goes against traditional wisdom, as you have said before. Like, you want to be very defensive and, plan for all of the possible inputs, etc. How would one go about possibly convincing a senior engineer, an engineering manager, or even their team or boss to approach or implement this type of programming style? Do you have any tips in that area?
Well, it's a difficult subject when you talk to engineer who haven't, who never came around this before. There are like intermediary steps. One of the things that you can do is suggest a throwing exceptions if debug, that kind of stuff. So it's not great, right? It's not great because you're still not going, if you don't run into the case in your dev environment, you won't see it. But I know that some people have started with that. You start with, okay, I'm going to enforce my assertions at when I'm in dev, which means that you're not going to get as much signal, but you should be able to detect those things early, and people should be fine with it because they're going to think, okay, it's never going to impact our customers directly. The reality, the real answer there is that when you don't do that, and when you're doing quick fixes, then you are impacting your code base with you're adding layers on layers on layers and hiding the problems, which means that when there is a real issue, you won't see it, and your customers are going to tell you, we don't understand, the screen is white, the button is not clickable, there's nothing, and
Right.
you're going to be telling them, I don't know, I'm not seeing any crash. Well, yeah, you did. If null, don't click on the button or something.
It's so true, right? Because the thing is, people and by people I mean most engineers, they somehow feel there's a difference between logical errors and there's like just crashes, right? Somehow logical errors are like okay, where like the app doesn't crash, but like you have like the screen with invalid data, and somehow that's okay, versus like how it's supposed to be rendering, right? Which is I guess the point that you bring, where like if you crash early, well, if you think about it, it is like the same outcome, which is like the user has not gotten what they wanted to see, but the difference is at least you have some more information now, right?
Yeah. So there's something else that you can. So it's a terrible idea in a way, but I need to share it. One, if you're worried about what your users will, you don't want your users to see this like my app has crashed, right? Well, it turns out that they don't have to see that, because the way things work, and I know some Googlers are going to hate me for sharing this tip right now, but the way this works is that you have a default exception handler set up in your VM, right? And this default exception handler just does a couple of things. It logs the stack trace to logcat, and then it calls into the system and says, please display the blocking crash dialog. And then when that returns, it calls system.exit, and that's what kills the process. So if you were to replace the default exception handler, the default encode exception handler, and do your own, where you should still exit the process because you're in a weird state. You shouldn't like try to recover. But if you let the app, if you basically restart the app without blocking on that crash dialog, then it's not great, but it's gonna essentially like flicker the app. Like the app is gone back, and users might not notice. And I have seen apps do that. You're like, I was here, and then somehow I was gone and I'm back here. That's a crash. Like you see apps that never crash. That's because they crash, but they hide it.
That is fascinating. I've thought about this, but I've never actually been bold enough to do this.
I'm not going to name names, but some social networks might be involved.
Some very large social networks, you mean?
Maybe.
It is tricky though, right? Because I remember a slight tangent here. So like I've been working with Kotlin a lot, and like I have this blog post that I'm going to write. Kotlin has this thing called to-do, right?
Yeah.
This to-do function basically crashes. And so I've basically written like a more forgiving to-do where essentially it does something similar to what you said, right? Like it actually crashes for developers. So if like there's a to-do and there's a developer is running the app, then basically it's just going to crash. And like the reason is because the intention with these to-dos is like a little different. It's not necessarily for crashes, but it's like, hey, you need to be doing this. Like, this is something I need to like swap this out with, with an SVG, or like, like I have like some of these internal to-dos and like, I don't want to like document these in a different project. I'll just write them in the code, but I don't want to crash for the users because this is really like a note to the developer, right? Again, like there's different opinions, but I think it's valid to point out that like not everyone is horrible if they're not necessarily immediately crashing. It depends on the context.
Interesting. I think the to-do is the equivalent, the Java equivalent of not implemented exception in a way,
Mhm.
right?
Right,
Yeah.
right. Yeah.
So we actually I have an interesting habit around to-dos. So we don't do that. We don't use those throwing to-dos yet. But so we used to have a lot of to-dos in the code, and one thing we realized there's some psychology to the to-do when you work in a team of more than a few people, which is, you see a to-do uh, without a name, or you see a to-do with a name. This is even worse when you have a name next to it, because you think, oh, it's this person, I don't need to care about this, and you move on with your life.
Yeah.
And the person might not even work at the company anymore. And so what to-dos have, the problem that to-dos have, it's that they don't have time context, and you don't really know. And sometimes, code moves around. That's another thing. Comments generally move around slower than code. You can do analysis on code bases, and you'll see that code moves a lot faster than comments, and you see comments that end up in places that are totally unrelated to what they're supposed to comment on. So the same thing happens with to-dos. And so we added a few changes to our sort of to-do policy. We still have to-dos. The requirement is you cannot put a name next to a to-do, because you
Interesting.
don't
Okay.
want to have any sort of to-do ownership. And the second one is you put a Jira ticket number next to the to-do, and that's an absolute requirement. And what that does is that it forces you to document, to leave a trace in the system, and actually spend the time writing, providing more context. And then people who see the to-do can quickly check the Jira and see, okay, when was this written? Okay, that was 4 years ago, and the person moved on to something else. We can probably kill this, right? So there's a lot more. It's been much better. Yeah.
One thing that we do with these forgiving to-dos that I talked about is we also force a date. So we basically give it a due date, right? We say hey, you got to do this by that date.
Nice.
And if you don't do it, and Kotlin also has, we have a very nice date helper. So it's easy enough to just quickly type a date saying oh, by 4th June, blah, blah, we need this to be done. And if it's not, then we'll go nuclear on you. So, so it's sort of
Nice.
yeah. So it's an interesting concept, the concept of assertions and forcing yourself, because in the end I feel the code is just the truest form of all source, right? Sure, you can have any other supplemental documentation, but if it's in the code, then I'm going to see it, I'm going to keep seeing it, right, every time I work on the code base. So
and we've used I've used this concept of dates for this offensive programming concept as well, where sometimes we have crashes where we get a crash and there's just not enough information to understand what's going on. And the natural tendency is to try to hide it or find a way around it. But I've been pretty strongly recommending to not do that, and instead find a way to capture more information and still crash, and capture more information that's going to help you figure it out. But then I usually add time sensitive things, so that a date. If you see this after, we have a release every 2 weeks. So if you see this after a month or 2 months from at this date, then talk to this person, and this should probably be solved by then, or we need to do something about this. I use that specifically in the context of a very rare but annoying Android bug that would lead the app to crash on updates. And it took us about a year to fix it by adding more information in every release. This was a crash that only happened during updates, and it would happen by so Android had some concurrency issues, the system itself, which meant that when you would install the new version of the app, and at the same time get on and off Wi-Fi, a broadcast receiver would wake up the old version of your code while the APK was being swapped out for the new version. So you'd get the old code running, but then you would try to do a call to get resources on the context, and that would return null, which is never supposed to happen. It's because it was trying to read the resources and the APK wasn't there anymore. And you'd get this weird, and the way we started understanding that is because we would get a stack trace with version numbers that didn't map so the crash reporter would give us a version number, and the lines didn't correspond. The lines of code in the stack trace didn't correspond. And that's because the lines of codes are baked in the bytecode, and that was the bytecode of the old version. But we asked the crash handler asked the system, "What's my version?" and the system would give the new version.
Wow.
So that was a very interesting bug to investigate.
Yikes.
And there's not much you can do about this, but what we ended up doing is we found ways to detect this, which is essentially resources are null. And when that happens, we just say system.exit, goodbye, we're going to be restarted soon anyway.
Yeah, those are not the fun kind of bugs to be dealing with.
No, not at all. I have a question here. So if there's a senior Android engineer, or any engineer for that matter, that's moving to another team that's perhaps maybe worked with you or worked in an environment similar to yours, and they kind of go join a new team, and they kind of notice that there's some wildly different consistency throughout the code base. And it's kind of scary to them. Do you have any tips to help them maybe help that new team kind of even, break it down, or to help them adapt into that new environment a little bit better so that you can start adopting more of offensive principles?
Yeah, I mean, definitely. I've made a lot of mistakes, so there's a lot to learn from that. One of the big mistakes that I think we all make at some point in our career is to come into a new code base and say, "Oh, this is terrible. The code is terrible. Everything is terrible. Who wrote this code? They don't know what they're doing." And while this may be true, that's not exactly what you're actually saying. What you should be saying, and what you mean is, maybe it's, "I don't understand this code." It doesn't mean that you're wrong, but it's just you're trying to read it and you don't understand it. The second thing you probably mean is, "I think the people who wrote this code at the time they wrote it, they didn't have the same, uh, understanding of the world,
Right,
and maybe
right.
the same good practices." And so you want to talk about how over time you have learned about this practice and how that is maybe a bad design pattern, and you're seeing it here. So you would like to know if maybe it is intentional, and probably not. What goes on is that a small company starts and they hire who wants to join, and they learn on the prototype, and it's a prototype. You're iterating a lot, so you're writing throwaway code, and that's totally acceptable. The problem is there is rarely a point where someone says, "Oh, this was the prototype. Let's start to build the actual product now." It's always the prototype becomes the product.
Wait,
And
people don't
so,
take time to just rewrite the app completely from scratch? Is that not a regular thing?
yeah, every 2 months.
Every 2 months.
You wish, right? I mean,
Yeah. Well, so that's the other thing, actually. We often see rewrites as like this golden standard. Like, we're going to rewrite the app and it's going to be so much better. But if anything, you quickly learn that that never works, and that rewrites never So when you join a company, you don't, or a new team, you don't really have context into the product. So if you were to do a rewrite right now, you would probably make a lot of mistakes because you don't really understand what's needed. The only person who probably should do a rewrite is someone who's been on the team for a long time and who wrote the first code in the first place. And so we found that, but they also have a lot of other things to do usually.
Yeah.
And I find that the best thing to do is to try to progressively improve parts of the code base and move forward. Because when you join a team, you have some amount of capital, I would say. Your people will believe you to some amount, will believe in you and want to do what, you have some influence. If you're junior, you don't have a lot of influence. If you're senior, you might have a name and people might listen to you. But if you burn all of that influence on rewriting everything, then all the product is going to wait for months, and they're going to say, "Who is this person who is rewriting everything?" And then we don't have the new features, right? So it's not the highest leverage thing you could do. If you're joining a team, you probably should focus on accelerating shipping and fixing the most important problems.
That is such an important point. And I know Don and I have talked about this over time, about how this is pretty costly, right? In the real world, especially with startups and stuff,
Yeah.
And also just over my experience and learning through my software engineering experience, a rewrite is that's 101 territory, right? You never rewrite the app because there's almost like there's very little reason for you to rewrite an app because it's almost always the wrong decision. Like, I loved your idea about how you progressively improve portions of the app. And I think it's actually, this is like also a very new point that I've not come across, where it's like this concept of how much capital you have when you join a new team, and you don't want to waste it. You want to use it to gain trust and then use that afterwards to like maybe do the rewrite, or at least portions. I love that concept.
Yeah, one of the other things that when you join a team, usually you are given some slack because people are trying to evaluate, they want to let you ramp up. So it's the best time to, so some people hit the ground running and, build a lot of new features. It's actually also a great time to learn and take the time. I remember when I joined Square, I was given time and I was given a bunch of small Jira's tickets to fix. And I spent a lot of time on them, way more time than I could have. But I used that time to learn more about Android. I would really want to understand why this crash was happening, and I would read all about the code in, the view class or the exception handler class or whatever, and that made me a better engineer. And the best time to do that, it's not when you proved your value, because usually you're also given a lot more responsibility. It's the moment you have the most time is usually when you join a team and people don't exactly know where you stand. So, you don't have to show off immediately. Just take a bit of time.
Right. So I guess like the other point that I had was you started this off with the concept of like debouncing, right?
Yep.
So where does so how did this concept of debouncing fit into like this realm of like offensive programming, right?
Yeah. And before we get going on that, what can you even give just a good definition of what debouncing is? Because there's a lot of folks out there who are still just barely getting into RxJava, and so the term debouncing is probably completely foreign to them. So any information on what that is would be greatly appreciated.
Actually, yeah. So if you look up on Wikipedia, you're probably going to get something very different from what I'm going to say. I think it's a term that comes from maybe electrical engineering. But that's not what we're talking about here. And also, so it's actually, it predates RxJava.
Yeah, for sure.
But so it's very interesting. So the way we I guess we run into this. So sorry, debouncing is the idea that put simply, imagine someone's tapping twice on a button, or imagine you're getting double events and you only want one, and so you're gonna debounce the second one and ignore it. Pretty simply put. So it's a way to deduplicate events that happen.
So let me ask you guys this: why? Let's just use a button click example, and I'm sure someone's thinking this driving in the car right now. We have this thing known as debouncing. It helps us kind of gate these calls. But if I'm working on a button click and I don't want someone to tap it twice, why shouldn't I just disable that button after the first click?
Yeah.
Or why not?
Yeah, you probably should, and that will solve probably a part of your problems, but not all. So let me actually just go back. I mean, this disabling the button is one of the best solution, but it actually doesn't. Android is tricky and likes to insert events in a bunch of places that you don't necessarily expect. One of the reasons you might not want to disable it is if you have a disabled state and then it would display differently, and when you want someone to tap, you might not want to show that the button UI changed. So then you'd have to go with that. But more specifically, so we run into debouncing because of that offensive programming idea where we put assertions everywhere. And so we had a big state machine that was what we call the payment flow. So you're supposed to insert a card, and then you're supposed to select a tip, and then you're supposed to sign on the screen, and then you're supposed to get a receipt. And so that's like a state machine. You're working from one place to another. And at the time, we used fragments with async transactions, and fragments and async transactions were really good at delaying things and enabling people to tap in a bunch of different places. And so what that would lead to is we are very assertive. We were like, okay, when I'm on the tip screen, I can tap on the tip button, and then that's going to drive me to, say, the signature screen. And now I'm on the signature screen, right? I tell my state machine, I'm moving to this screen. I should now be on this screen. But then the user types on some other tip button that's trying to inform the state machine to do something else. And the state machine is telling, no. You're in the signature state now. You cannot try to do these operations. You crash. So that's how we started
Interesting.
discovering this.
Oh,
Yeah.
interesting. Okay. So that's like the root cause where like you started to see like this. Yeah, there was like clearly like
Yes.
some
And
problems.
so
And just a side note, I know you guys love fragments. You wrote like that post on Square where you said like fragments are the best. Everyone should be using fragments, right? So.
yeah, we could do a whole episode on that, but I'll just let you the anyone read the blog post. It's probably still out there. The story from my side is that I had been doing Android for a while with activities. I saw fragments coming around, like really, I wasn't enjoying them, but I was like, why not? And I joined Square, and we had just moved everything to fragments, and I was like, okay, are you sure you know what you're doing? But you're Square, you know what you're doing. And it was a nightmare. Our crash rates went way up, and we had all these things to handle. And then we slowly backed away from fragments.
So sorry, you were saying that made sense. Like your explanation of the problem made sense. Basically, you have this state machine, and the state machine does not expect some, like it indicates that like you're in a state where you're not supposed to be getting certain inputs, but you were, and so you were crashing. That's like,
yes.
Yeah. Okay.
Yeah. And so what we started doing immediately was coming up with ways to solve this, right? So one of them was stop using fragments and async transactions, because that meant that instead we would just use animations and swap in views and swap out views. And so we would know, okay, now I said I would go there, and I just inserted the new view, and I'm just starting the animation right now. I'm not waiting for some future post. And then the other thing that we did immediately was, which is what you were talking about, Don, a little bit before, which is we would just override dispatch touch events in the root layout. And we would say, well, why, as soon as I said I want to go there, and while I am animating, I don't let any touch event go through. So no one can actually tap anything. You can't mess with the previous screen, and you're going to wait a little bit. And so that turned out to work for, all right. It seemed so, at least.
Sorry, quickly, just to follow up, because I like this idea, but I want to understand clearly what you were doing. So basically, anytime you start a transition or you start a point where you're moving to a different place and you don't want any inputs, you would disable all inputs, and you do this in like your root activity or something. How would you go about doing this?
Oh, so it's actually pretty simple. So we use something called flow, but I assume you could do something similar with fragments. You have a central place where you're saying, you know what, I want to move from A to B, and you're starting an animation, and that central place has access to a root layout in your activity, a custom view that's just like a frame layout or something like this. And so touch events are dispatched hierarchically. So every touch event gets in from the top. So all you have to do is that root layout, the central dispatch, the thing that knows, oh, I'm going to move from here to there. That central dispatch tells the root layout, hey, now you should stop letting any event go through. And then later it tells, okay, now it's time to listen to touch events again. And you could actually do that in the activity as well, depending on where you want to do it. You can override touch events there, I believe. And so we did that, and it got rid of most of the problems. So removing async transactions and ignoring touch events, but not all of them. And that's because at some point in some version of Android, clicks became delayed. So what happens is that when you get an event that's touched down and then an event that's touched up, and it used to be that as soon as you have touch up, the onClick is fired. But what they implemented at some point, I don't remember the API, is that as soon as you press touch up, a runnable is enqueued to actually start the onClick a bit later. And I think that was for animation purposes, so that you would have a few frames with the state. But what that created was that if you double tap quickly, you would then basically process those two up events and enqueue runnables in different views. And then the first one gets processed, and it says, okay, now I want to stop listening to touch events. right? So no new touch events. But the second runnable is still enqueued and it's going to be dequeued and executed. So if you
So
were to
you've
press,
not
yeah,
basically canceled the event. You've just stopped it from happening now, but it will happen later, and which is even more
yeah,
problematic. Okay.
you basically cancel new touch events, but any click that has been enqueued is still enqueued. And so there's an API for that on Vue, and I think it's API 19, and I think it's something about cancel pending input, something like this. But it's only API 19, so if you're not on API 19, you cannot use it.
Oh, interesting. Okay, so this is not something that I'd run across before. So this is pretty cool. I'll add that. Yeah.
And so what we ended up doing is, and it's not great, but it worked, is we replace all of our on-click listeners with a class that basically we call it DebouncingOnClickListener, which is just a class that implements it and delegates, and you have a do click instead of an on-click. And what it does is, yeah, so that's kind of annoying. But what it does is that there is a static Boolean on that class that says, am I currently enabled or disabled? And every time we get one of these fires, it gets an on-click, then it turns the Boolean to disabled. And then it posts on the main thread to re-enable it. And what that does is that it's going to be re-enabled on the next, when the current things that are enqueued are dequeued. So imagine you're on the main thread, you're dequeuing an on-click and executing it, and that causes the debounce listener to set its boolean to I'm disabled now. Then you get a bunch of other runnables that were enqueued, and they all get executed, but they all run into nowhere because the boolean says I'm disabled now. But and then the first debounce listener has posted, so eventually the queue is empty and gets to that posted event, and then it re-enables itself. And so this happened mostly when the main thread freezes. If the main thread is freezing, you can touch the screen and it's going to enqueue a bunch of events, and that's going to create this to make this happen a lot.
Yeah, this is very interesting. I never knew this is like something that there was a strategy. And did that work well?
It did. Another thing we did, and that's I'm not super proud of, but it solved a lot of issues as well. So basically, we're really trying to prevent people from doing different things that are supposed to go in different directions at the same time. And so when Android introduced better support for multi-touch, you could basically use your two fingers to touch two different buttons at the same time. So very quickly we just disabled, multi-touch.
Wow.
Yeah,
So, and
because
this is something that we talked about like previously. You said you can hit like the back and forward button simultaneously. Is that
yeah, that's actually whenever someone shows me an app and it's like try to break it, it's actually not that hard to break any app. You just try to press all the buttons and press back and next at the same time, and usually some magic happens.
Wow. I'm so scared to even try that now. Like, I don't even want to try that in any app.
Do you mean like the back and next button inside of their application, or are you talking about the back button on the actual device?
Actually, both. So if they do everything right on the UI, maybe you can't do it on the buttons, and then I use the hardware back button. And similarly, you can. We actually the things that the piece of code that handle on back press also looks at the debounce boolean and ignores any back press if we just if we realize that the main thread was blocked and we just dequeued a bunch of events.
Okay, so I understand the problem now. So assuming I'm like a super master UI input like speedster or something, and I have like multiple events and I do it so fast that even before like in a way where like it registers more than one event, right? So how did you go about solving this? So this DebouncingOnClickListener is like one approach. Did you stick with it? Is that the approach that you use today?
Yeah, it's still the approach we use. This was actually baked in Butterknife at some point. I don't know if it's still there. I mean, it's been working great. That combined with, combined with the canceling touch events and removing multi-touch, we haven't had that many issues or really any issue. This was really a problem for low-end devices because they would, freeze all the time, and you could really see that all these crashes related to state issues were on low-end devices.
Are there any other strategies that you use, or this is like the ones that give you? Because I know like you can actually just write like a debounce, like using Rx, you can maybe like write a button click debouncer or something along those lines, right?
Yeah, and we've been using more and more of Rx, so definitely trying to debounce, but it's the same thing. For on-click listeners, I could consider it, but I like the idea of understanding what exactly is going on in the system, right? And so we've actually had bugs where sometimes we would debounce Rx events and that would hide another bug that would, where instead if we had crash, we would have seen the bug. One other thing that I want to mention that was an interesting research is disabling touch events. So you override dispatch touch events. You need to be careful though. You want to disable new touchdown events, but you still want to forward touch up events. So because what happens is that if you get a down and a bunch of move, and then you decide because something else happened, like with another finger or something, and you decide, oh, it's time to, or you decide you had an automatic transition and you decide it's time to move and stop listening to events, and you don't let the up go through, then there might be code down the lines that has state and expect that up, right? So view pager is one example of this. If you mess with if the events that get to a view pager are down, move, and then there's no up, and then you start down again, you're gonna get a crash because it doesn't expect that to ever happen.
Yeah, Android is tricky, man.
Yeah, there's a lot.
So if someone wanted to, I mean, we're talking so much about how to handle this. Butter Knife has the DebouncingOnClickListener, which we'll put that inside of the show notes. We've talked about the RxJava debounce, again, that'll put in the show notes. And then also the cancel pending input event stuff, which we've talked about as well. Other than this podcast about folks possibly learning about these problems and going back to their desk and breaking their apps and kind of face palming for the next 10 minutes, what would you recommend kind of maybe someone should do to kind of get the high level, maybe possible crashes out of the way? Is there anything else that, like you said, that you go up to someone's app and you can like break it in the first couple of minutes? What would be those couple of things?
Hire Piwai as a QA tester.
Yeah, I'm afraid now that it's going to be a challenge. People are going to come to me and ask me to break their app. Let's see. So I would say that, I guess I give tech talks on this, but I think I gave a talk called "Crash Fast and Furious" that covered some of these elements.
Nice. We'll make sure to add that in the show notes.
Cool. But other than that, really, to me, it's hard to, it seems like it's good engineering practices, right? So it seems like it's hard to say you should go read. I actually don't think I've read a book about handling crashes. The thing that has taught me the most has really been reading source code, and I would say reading the source code of Bugsnag or Crashlytics will actually teach you a lot about how to handle crashes and how all of that works. You might end up being scared and wanting to write your own, but that's probably not a better solution either. And then reading the Android source code. One of the things that's the most important is that to realize that you cannot fix every single crash. So that's why you need tools that are going to tell you which crash happens the most, and then you're going to focus on that.
Got it. So 0 crashes is not something that I should aim for.
Yeah.
Okay.
Sadly, well, if anything, because Samsung, right?
Why you got to bring that up? Almost went a whole episode without saying that word.
Yeah, I have to say it's been less of a problem recently. So congrats, Samsung. I have not had as many as I used to.
Yeah, I'm still a little bitter. I'm not gonna.
It depends on what APIs you're dealing with, I guess.
Yeah, true.
All of them.
Yeah. So yeah, I mean, there's really, to me, it boils down to a few principles, which are never try to just every time you see something where you're trying to do a quick fix, hold on for a second and think about the problem. Think if you can understand what's actually going on. That's just going to make you a better person, a better engineer. I mean, better person, maybe not.
A better
actually,
person too. Yeah, probably. No, but that's a very good point that you made. Like the idea is to understand And I guess like the other thing is like, can you reproduce it, right? Like if you can reproduce it, then you understand it to at least some extent, right?
Yeah, that's actually a very interesting topic. I'm sorry, I'm not talking about resources at all, but it's just we keep talking about
No, this is
interesting
good. This is
things.
all
And
good.
so reproducing is one of the hardest things, right? Especially when you're dealing with crashes. And so there are a lot of things you can do to help yourself reproduce crashes. And really, one of the best thing is something a concept called breadcrumbs. It's the idea that you have some sort of rolling logs, and as you navigate through the app, you add entry to this log. It's almost like logcat, but maybe like a logcat information, right? But you would store that and associate that to the crash. And so all of the crash handlers have this notion of like adding logs. So if you add a rolling log of like, okay, this happened, and then this happened, and then this happened, then when you look at a crash, you can actually sort of visualize the path of the user and try to reproduce what happened.
Right. And I mean, I know we have used Crashlytics in the past, and the Crashlytics has like a breadcrumbs feature, right? And Bugsnag, I believe, like is what you folks use at Square, and like that also has like a breadcrumbs feature, if I remember
Yes,
right.
and that has, so in our stuff, what we do is we put screen navigation, but also HTTP requests and their response. Because that often like, you got a 400 and then you clicked on this error message and then you went there, right? So that often informs that in different states, really. The other thing we use that's been super helpful for us has been dumping the view hierarchy as a string into the crash.
Oh,
so
interesting. What is that about?
So basically, you get a hold of the root view and you iterate through it as you're crashing in your crash handler. And you iterate through it and you capture the name of the views, their IDs, and a bunch of information. And you attach that as metadata to the crash. And then it's like this, it's almost as if you are looking at a screenshot of the crash, but for much cheaper cost. Like you don't have to upload a bitmap.
Oh, interesting. Do you have like a strategy here? Because like this is again something that I've not come across before. Like, do you folks like? Do you have like a blog post, or do you plan to write one or something along those lines for this?
Someday, I've been wanting to open source and write about this for a while now. It's not actually that hard. You essentially get the root view and iterate on children, and you capture the names and a bunch of other things, and you return that as a string.
Do you do this at the uncaught exception handler thing that you override, or
yes? Yeah, we do that there. We capture what we call our scope hierarchy. So we use Dagger and scopes. We also capture the scope hierarchy in a very similar way. Yeah, a lot of information. You wouldn't believe all the information we have in crashes, and it's not useful every time, but it can be very, very useful.
Yeah, but when that one time and it is useful, it's like almost the only way you could have figured it out.
Yeah,
right?
like one of the view hierarchy has been amazing when something really weird happened, like this view is present twice, or you seeing the two views are still attached to the view hierarchy, and like something forgot to hide. So usually we also put like whether a view is visible or hidden, and that can teach you a lot.
And you do this all in the uncaught exception handler state. So basically, because at that point, like your app is anyway going to crash, so you don't have to worry too much about like the experience. You can just like try to grab as much information as you want.
Exactly that. Yeah, and so that's one of the that's been a really great tool. It's not always useful, but it's been a really, really good tool. And one thing I wanted to touch on around so we talked about NPEs. So what I would advise engineers is look for these patterns that you do, and next time you see them, when you do them, or you see that in a pull request, just ask the question. If you see a pull request or yourself, and it's basically fixing this crash, that's like the title of the ticket, and then you'd see if null return, then you just hold on, think about it. Am I really doing the right thing? Am I really understanding what's going on? Maybe you are. Maybe you could dig further. Along similar lines, I think there are two other things that I generally advise people to avoid. One of them is using weak references to solve memory leaks. And I've seen that in many, many places. So thanks to LeakCanary, now you know that you have memory leaks. And I've seen that in code bases where people say, oh, I had a memory leak here, so I just used a weak reference on that object, and then it wasn't leaking anymore, because a weak reference is a reference that's going to
Get released. Yeah.
get released if nothing else is holding on to the object. And that's not the answer, because that might be the answer, but not always. You need to understand why something was leaking. Like there's a container that's leaking, and it's leaking the reference. And so by using a weak reference, you may be clearing the reference that was detected, but the container is still leaking anyway.
Got it. Like you're basically avoiding like the end state of the problem, but like that thing should never have happened in the first place.
Exactly.
And that's not being solved. Okay.
And the last one that's been amazing to me is, or that we all do, is post delayed. So when you do or post on the main thread, you have some code that's calling, and you realize that it's out of order, and you're like, oh wait, this should have happened before that. And so you fix it by adding main thread.post, and I'm going to wait, this is going to happen, and then I'm going to do the other thing.
Oh, interesting.
So
okay.
Yeah, solving ordering issues with post, but really usually when you have an ordering issue, you have a deeper problem. You need to understand the problem, not just quick fix it and think, because it's basically, this is going to happen after sometimes. I don't know when exactly. If you're writing imperative code, right, you're writing A happens and then B happens, B should be right after A. And yeah.
That's pretty cool. I like those tips. Those are like pretty practical sort of like tips. This has been amazing, Piwai. It's always very interesting talking to you, because like I've seen you break and sort of like dive into parts of the app and the Android ecosystem that people usually don't tend to do. So this has been a lot of fun. Thank you so much.
Yeah. If I may say a word on Square, one of the things that I want to highlight is that we do open source, we do payments, but we now also do APIs. This is kind of the product pitch minutes. And that's my team, actually. So my team is working on payments APIs. And so, obviously there's the usual, like Square is hiring and have more engineers. But more than that, if you're interested in taking payments in your app, go check out Square. We have some stuff.
Very nice. And if you want to see all the funky things that Piwai is doing with his uncaught exception handler, then like that's a good way, I guess, right? You can find out all that.
Don't look at the code.
Cool.
The thing that I talked about, how we would kill the app if we detected this bad situation. The method is called jump ship if app is syncing. And so we like to have fun with names. Yeah.
Oh, perfect. I love that name. Jump ship if app is syncing. Fantastic. If people want to find out the other cool names for the other crazy methods that you have, Piwai, what's the best way people can reach out to you?
Yes, the best way. So I'm on Twitter, twitter.com/PIWAI. And you know what? You can just email me, py@squareup.com.
Perfect. Thank you so much. Don, if people want to find out how you jump on your ship if your app is not syncing, what is a good way to do that?
The best way to get a hold of me is going to be through Twitter, and that'll be at DonnFelker. Now, if folks want to see what your ship is and all that good old stuff, how do they get a hold of you?
Kaushik Gopal, my first name, last name, on Twitter is usually the best way. Twitter is usually where most of us are pretty responsive. All right. So thank you so much, folks, for listening. Piwai, thank you so much. This has been amazing.
Thank you.
That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.